Well, greetings everybody. In today's video, I'll be telling you what a function is, and I guess it's an important video for the reason that many things that you encounter from now on to the end of the semester will be described as functions, okay? Equations will be described as functions, graphs, pictures, all sorts of things. So it's important that I tell you what it is now. So part one, what is it? So when we say y is a function of x, what that means is that x and y are two things that are paired together in a way that each x is paired with exactly one y. So when it says there that each x is paired with exactly one y, we mean not two y's or not three. You get the idea. Exactly one. Pair two things together and every x is paired with one and only one y. Okay. Now I understand that when in math we give a definition of something, that needs to be followed up immediately with an example so you can see what I mean. So here's an example of a function. The format of this particular function is that I have an ordered pair. Do you see this thing, that the parentheses separated by two numbers and a comma all in there? Okay. What that means is that this first number is the x, the second number is the y, and those two numbers are paired together. Okay. All right. There's x and y are paired together. So here's my function. It's a list of ordered pairs. The way I would read this function is that the x being 4 is paired with y being 8, and x being 1 is paired with y being 2, and x being -1 is paired with y being 2 also. So is that a function? Is it true that every x is paired with exactly one y? I'd say yes, that's true. Every single x, like 4 is paired with 8. It's not also, if you look around, it's not also paired with some other number. And 1 is paired with 2, and -1 is paired with 2 also. So yes, it's true. Every x is paired with one and only one y. Okay? 1 is paired with 2, -1 is paired with 2, and so on. So yes, we would say that does define y as a function of x. Okay? Now, if I had another ordered pair, that say like this list had one more, and it said -1 is paired with 3, well then it wouldn't be a function, because in that case, if I included this fourth ordered pair, the x value of -1 would be paired with 2 and also with 3. That would give you one x being paired with more than one y. Okay? And so that's the kind of thing that we look at to eliminate something from being a function. See, as I have it right here, when I added that last ordered pair, this one value of x got paired together with two different y's, and in that case, that would make it not a function. Now, as I originally had it, before I added this last one in there, it was. But then I added the last one in there so you could see the difference. So you could see what, for example, would make it not be a function. Okay? Anyway, all right. Now, I know that this needs some context. This does seem like a silly thing all by itself. Because you could be like, so what? You can pair numbers together. So what? Who cares? Why does it matter if each x gets paired with exactly one y? And why is it maybe somehow bad if one x is paired with two y's? Okay, let me give you an example. Let me give you a way to think about this. Okay, so part 2, examples of functions. So here's something that is realistic enough and provides you with enough context for why mathematicians, scientists, and engineers think of functions the way they do. Here will give you a reason, or at least a way to understand why we think of functions like this. Okay, so here's my function. Now here I'm providing some context. I'm trying to provide some reality to this idea. So let's say that x will be the time of day and y will be my location. And my function, perhaps, is just a pairing of what my location is at various times of day. The format of my pairings, once again, will be that in an ordered pair, in a set of parentheses, the x and y that'll be paired together are written that way. Okay, so let's look at it. It says, at 7 a.m. I am at home. Those two things get paired together. At 9 a.m. I am at school, and at 5 p.m. I'm at the park. Okay? All right. Now, this is possible. This could happen. Like, maybe that's really how my day went. And notice it fits my definition up here of what a function is, that every x is paired with exactly one y. There's no one value of x that's paired with two different y's and so on. So this is a possible description of my day. It's a possible way that you could pair these things together, and this is a function. Now think about what it would look like if it wasn't a function. Okay, then my day would be something like this. At 7 a.m. I am at home. That's what 7 a.m. comma home means, that 7 a.m. is paired with home. And then the next one says 7 a.m. I'm at Jeff's house, whoever Jeff is. Okay, and then 9 a.m. I'm at school. Well, so two things about this. First thing is, this is impossible. How can any person be at two different places at any one time? How could you be at 7 a.m., you're at home, and at 7 a.m. you're also at Jeff's house, assuming that Jeff's house is some other place besides home, right? Okay, that's impossible. But that's also not a function, right? What did we say a function was? Every x gets paired with exactly one y. Well, in this case, this one x value, 7 a.m., gets paired with two different y's, home and Jeff's house. And that's what we said would make a pairing like this not a function. All right. So if you think about this way, we could say, well, a function is a pairing that could actually happen. Okay. And if it wasn't a function, it would be because of some impossibility, such as being in two places at one time, which no person can do, right? Okay, all right. Now, hopefully that provides a little reality or some context to it, as far as what's a function versus what's not, in light of what would be possible in this scenario versus what's not possible. Okay. All right. Now, I think when you're doing your assignments, you probably won't see many functions like this. So let's look at an example that I think is more like what you encounter on the assignment. So real quick, a little vocabulary. Whenever I list a set of ordered pairs, which is what this is, and this is what, everything I've written so far has been like this. We put these curly braces, and then we put a list of ordered pairs in it, okay? And that, this first number is paired with the second number and so on. All right. So when you have a list of pairings like this, a list of pairings of paired numbers that may or may not be a function, we call this a relation. So let's say that I give you this relation. That's what you have. And what I want are you to be able to answer 3 questions. Could you tell me if it's a function or not? Yes or no. Can you tell me its domain and range? Which I haven't talked about domain and range yet. Okay, so let's decide if it's a function. Is it like this, where every x is paired with exactly one y? Okay, or is it like this one, where I had this one x value paired with 2 different y values, reflecting on this impossibility here? Let's see, 0 is paired with -1, 4 is paired with 2, 7 is paired with 2, -1. Yep, so it's not true that I can pick out one x and then draw this double arrow saying that it's paired with 2 different y's, okay? So is it a function? Yes, it is. For that reason, that every x value is paired with one and only one y. Now, let's go from there to the domain and range. Domain and range, very simple. They're really just vocabulary words. You don't have to do any calculations to figure out the domain and range. The domain is the set of all possible x's, and the range is the set of all possible y's. So we might list it like this. We might say, okay, the domain being all the individual x's, 0 is one of them, 4 is one of them, and then 7, and then -1. Okay, so there's your domain. which is an exhaustive list of every possible x in this function. The range, similarly, the exhaustive list of all the possible y's. Well, I've got -1, I've got 2, and then I've got 2 again. Should I list it twice? No, I'm not going to list it twice. It wouldn't do any good. It wouldn't provide any additional information if I listed it twice. We'll list it once. So -1, 2, and then 4. And then there's your exhaustive list of y values, otherwise known as the range. Okay? All right. Now, hopefully, taking things up to this point will give you the definition of a function, recognizing some simple examples of it, and as a bonus, hopefully this will provide you with a context or a basis for a function being what it is, about this possible situation versus this impossible situation. So let's do something else there. When I started the video, I said that many things throughout the semester will be called functions, okay? And I want to have like a brief survey of those types of things. So a function is anything that pairs two numbers together in that way. Or you pair two numbers together where one x gets paired together with only one y. Not two y's and not three, okay? Now that could be an equation. So here's an example of an equation that does that. See this equation right here? Capital C is 5/9 capital F minus 32. That is the equation that will convert a Fahrenheit temperature to a Celsius temperature. That is a function, okay? The Celsius temperature is a function of the Fahrenheit temperature, meaning that for every Fahrenheit temperature you can think of, this equation will pair exactly one Celsius temperature with it. For example, if I put 41 degrees Fahrenheit into this equation and subtract 32 and then multiply by 5/9, I will get 9 degrees Celsius, okay? So if I put in one x value, and here the x value is the Fahrenheit temperature, I will get exactly one y value. And in this case, the y value is the Celsius temperature. So a function could be an equation. A function could be a list of ordered pairs like this. That's one possibility. A function could be an equation, such as this one, which pairs together Fahrenheit and Celsius temperatures. Now, a function could be an equation that is like a scientific formula, such as this one, or it could just be an algebraic equation. Do you see this equation? Y equals x squared minus 2x plus 3. In that equation, y is a function of x. What that means is for any number x that you could ever plug into this equation, you will get exactly one y value as a result. Plug in an x, square it, multiply by 2, subtract, add, you're going to get one y every time, okay? So that equation also gives a function. And then last, a function could be a graph. So what is a graph? You think of, here I don't have graph paper, but you know graph paper has all the squares on it, and you can go left and right and up and down. And if I had a graph on graph paper, any point on that graph would be how far right I go to get to that point and how far up. You know, so right here, I'm saying that, you know, I go 4 spaces to the right to get to that point, but then I go 3 spaces up and I'm there. Well, that first number is the x value, and that second number is the y value that gets paired with it. So in this particular graph right here, there are all these points on it, more points than I have deliberately marked, but in every single point, there is an x and a y, and on this graph, it's such that every x gets paired with exactly one y. So you look at this graph, you see the x value of 4 gets paired with y being 3. There is no other point on here that could allow for x being 4 to be paired with something else besides 3. That point makes it 3 and 3 only. Okay, so a function can also be a graph. The points on this picture, on this graph, pair exactly one y with every x, and so that's a function too. Okay. All right. Now let's talk about one more thing. Are all equations functions? So I'll give you two equations and we'll see that sometimes not. So here's an equation and I ask you to consider the question, does this equation define y as a function of x? So what would that mean? That every x gets paired with one and only one y? So in this equation, it turns out to be true that yes, for any number x that we could possibly plug into this equation, we will calculate exactly one y. Let me show you how. Now I have to pick a number just for the sake of illustrating this, but what if I let x be 4? Okay? What y value gets paired with this according to the equation? Now real quick, one thing I didn't mention is, if a function pairs numbers together, those numbers could be paired arbitrarily like this. This says 4 gets paired with 8. It doesn't say why or how. It just says that, as a matter of fact, happens. And then here, I actually gave you a rationale for the pairing. I said 7 a.m. gets paired with home because that's where I am at 7 a.m., okay? But the rationale for the pairing might vary. Here, the Celsius and Fahrenheit temperatures convert according to a mathematical formula. That's the pairing. Here, the value of y that gets paired with the value of x being 4 is determined by this. So put the number in and see. 4 minus y equals 6. I want to solve for the y. So what if I move the 6 over here and the y over there? It would say y is equal to 2. So x being 4 gets paired with y being 2. That's what makes it a function. For every x that we could possibly plug in, we will only get one y. There's no way that you would get another y value for whenever you plug an x in, okay? It's just impossible. You plug the x in, you solve for the y, you'll get one result. Okay, so this equation does define y as a function of x. But here's one that doesn't, okay? This one says y squared equals 1 plus x squared. All right. So this equation does not define y as a function of x because some x's will lead to calculate more than one y. So a function is such that every x gets paired with exactly one y, but this one's not going to do that. Now I realize if you've never seen this kind of thing, you might not know, have any way to figure out how that is, but I'll show you. So let's let x be 0, okay? And I'm going to put in here and see what y gets paired with that number. So if I do that, it will look like this. Y squared is 1 plus 0 squared, but 0 squared is 0, so I get y squared is equal to 1. And in algebra, if we ever solve for a square, we would take plus or minus root. Okay, so my y value, if I solve for it, is going to be not square root of 1, but plus or minus root 1. So I'll get 1 or negative 1. So here's what we see. If x is 0, that gets paired with y being 1 on one hand and negative 1 on the other hand. Okay, so I get 1x paired with 2 y's. And that's why it's not a function. The nature of this equation is it's possible that 1x gets paired up with 2 y's. Okay, all right. Now, in fact, it's the square that makes this not a function. When you solve for a square, you solve plus or minus. Now let me say a little bit about that. Some people find it strange that when you solve for a square, like if it says y squared right here, you take plus and minus root of the other side. Okay, so I'll show you why that is. Let's say I'm saying if x is 0, it gets paired with y being 1 or negative 1. So that would look like 0 squared equals 1 plus 1 squared. Okay. Oh, whoops, I got that backwards. Okay, 1 squared equals 1 plus 0 squared. So here I'm putting 0 for x, and I'm putting 1 for y. And then that checks out. 1 squared is equal to 1. All right, so x being 0 and y being 1 is a valid solution to that equation. You can plug 0 in for x and 1 for y, and it works. On the other hand, if I plug in negative 1 for y and 0 for x, it still works, because what's negative 1 squared? What does it mean to square something? To square something, you multiply that number by itself. So negative 1 squared is negative 1 times negative 1, but that's positive 1. And over here, 1 plus 0 squared, well, 0 squared is 0, plus 1 is 1. It still works. So that's why when you solve for a square, you get plus or minus. It's also why in this particular equation, 1x gets paired with 2y's. Both of them work in the equation, and it's not a function. All right, so hopefully that gives you various levels of explanation for these. You can take it deeper like I did right here, depending on how far you want to understand it. But for now, if I can leave you with the concept that a function is anything that pairs every x, whatever you say the x is, with one and only one y. Any situation that leads with that is a function.